From dawn to dusk, farmers across continents are entering one of the most intense harvest seasons the world has ever witnessed. Fields are overflowing, orchards are heavy with fruit. The 2025 season is delivering record-breaking yields, with billions of tons of fruits and vegetables ripening all at once. In this episode, we'll uncover how farmers are battling chaos and climate change to bring in the abundant, colossal harvest of 2025. Each year, global bell pepper production exceeds 38 million tons, with China, Mexico, Turkey, and the United States being the largest producers. As one of the most delicate vegetables in the world, hand harvesting remains the dominant method in many traditional growing regions. Farmers pick each ripe pepper by hand, cutting the stem with scissors or small knives to avoid tearing the skin or breaking the branches. Standard quality peppers are typically red, yellow, or deep green, with smooth, glossy, unblemished surfaces. However, at large-scale farms in Spain, the United States, and the Netherlands, mechanical harvesting technology is being increasingly adopted. Bell pepper harvesters use soft conveyors and vibrating mechanisms to detach the fruit, helping reduce manual labor and double productivity compared to hand picking. Color and size sensors are integrated directly into the harvesting line, allowing preliminary sorting to take place immediately in the field. A further advancement is robotic harvesting in automated greenhouses, currently being tested in Japan and the Netherlands. Robotic arms equipped with AI cameras and 3D sensors can detect the color, ripeness, and position of each pepper, then cut and gently place it into collection trays. Economically, the global bell pepper production and trade industry is valued at more than $60 billion annually. In fact, demand for bell peppers continues to grow steadily by 3 to 4% each year, driven by healthy eating trends and the need for year-round vegetable supply in temperate countries. Now, let's explore the papaya harvesting process on a global scale, one of the most widely consumed tropical fruits in the world. Today, global papaya production exceeds 17 million tons per year, with India remaining the leading producer at around 6 million tons, followed by Brazil, Indonesia, Nigeria, and Mexico. Papayas are generally harvested year-round, with peak seasons falling between March and September, depending on the region. The ideal time to harvest is when the skin begins to turn from green to pale yellow, the surface appears glossy, and the fruit releases a subtle fragrance. Harvesters use small knives or gently twist the stem by hand to detach the fruit, placing it carefully into padded baskets to avoid scratches or bruising. For a fruit that ripens quickly and bruises easily like papaya, gentle handling and same-day transport are crucial to maintaining export quality. Thanks to its high yield and continuous harvesting cycle, papaya generates billions of dollars in economic value annually, not only as a fresh fruit, but also through processed products such as juice, jam, and papain enzyme, a key ingredient in the global food and pharmaceutical industries. Indonesia is currently the world's largest pineapple producer, with an annual output of about 3.2 million tons. The main growing regions are Lampung and South Sumatra, where the humid tropical climate and fertile red basaltic soil provide ideal conditions for pineapple cultivation. During harvest season, farmers skillfully cut the fruit close to the base with sharp knives, leaving a short stem to minimize moisture loss. Manual harvesting allows farmers to select fruit at perfect ripeness, preserving the golden hue and preventing bruised eyes, a crucial factor for whole fruit export standards. Properly harvested pineapples retain their sweetness, crisp texture, and signature aroma throughout long-distance transport, reinforcing Indonesia's position as one of the world's leading pineapple exporters. Indonesia's pineapple industry is not only massive in scale, but also vital to the national economy. Export revenues from fresh and processed pineapples exceed $2 billion each year, fueled by strong demand from the European Union, Japan, China, and the United States. Canned pineapples and juice account for a significant share of export value, driven by the global appetite for tropical products. They say the world is divided into two teams, those who love pineapple on pizza and those who would never allow it near a slice. So which side are you on? From the Yunnan valleys of China to the fertile plains of central Chile and across Eastern Europe, millions of plum trees are heavy with ripening fruit. In 2025 alone, global plum production is projected to exceed 12 million tons, serving both domestic markets and international demand for fresh and dried plums. Between June and August each year is the most suitable time for harvesting, when the fruit reaches optimal ripeness and its highest sugar content. Farmers usually harvest early in the morning to preserve freshness, picking by hand or using specialized tools to minimize scratches and bruising. China currently dominates the global plum market, with an output of about 6.75 million tons, accounting for more than 54% of the world's total production. Premium varieties such as Black Amber and Friar are in high demand in Japan, South Korea, and European countries, selling at retail prices 2 to 3 times higher than domestic plums, ranging from $2,000 to $3,500 per ton, depending on the season and quality. With its distinctive fragrance, widely appreciated, but its soft texture, high susceptibility to bruising, and short ripening period, peaches are considered one of the most temperamental fruits in the world. The peach harvest season usually takes place from May to September, depending on the region and variety. Farmers typically harvest entirely by hand, selecting fruits that have just reached commercial ripeness. When the skin turns yellow-orange, emits a light fragrance, and still retains enough firmness to withstand transportation. Each fruit is picked with a gentle twisting motion and placed into padded trays to prevent scratching. Each year, global peach production reaches about 25 million tons, with China, Spain, Italy, the United States, and Greece being the largest producers. Due to the sensitivity of peaches, full mechanization remains a major challenge, especially as appearance and color standards in exports become increasingly strict. Consumption continues to rise in Asian and European markets, particularly in the premium fruit segment, where peaches are regarded as a symbol of summer and freshness. Each year, global banana production exceeds 125 million tons, 5 times that of peaches and 10 times that of plums, making bananas the most consumed fruit on the planet. India, China, the Philippines, Brazil, and Ecuador are the largest producers, with India leading at more than 35 million tons per year, mainly for domestic consumption. In traditional growing regions such as Tamil Nadu and Maharashtra or Los Rios, banana harvesting is still done manually. The work is usually carried out by two people. One uses a sharp knife to cut the bunch at the base, while the other supports it from below to prevent bruising. Each bunch can weigh 25 to 30 kilograms, trimmed, sorted on site, and then transported to the processing station. At large-scale farms in Latin America and Southeast Asia, overhead conveyor systems, cable transport, and automated post-harvest handling technologies are widely applied, helping to reduce labor costs and mechanical losses. According to the FAO, more than 400 million people around the world currently depend directly on bananas as a source of income or staple food, turning this humble fruit into a vital livelihood link for hundreds of millions of farming families globally. Instead of being discarded as before, most of this biomass is now efficiently reused in a circular agricultural system. Today, thanks to mechanization, banana stem shredders can process tons of material per hour, turning it into green manure or bioorganic fertilizer, helping to improve soil structure and reduce up to 30% of chemical fertilizer use for the next crop. In India and the Philippines, banana fiber recycling projects have helped reduce more than 200,000 tons of agricultural waste each year, while contributing to carbon emission reduction and promoting sustainable farming models worldwide. Because spraying pesticides by hand takes too much time, we now continue our journey with a high-capacity mist sprayer used in large-scale agriculture. Suitable for many types of crops such as rice, corn, and fruit trees. This device uses a high-pressure jet fan system to disperse pesticide or foliar fertilizer solutions at a flow rate of up to 375 liters per minute, spraying up to 300 meters in just a few minutes. This type of machine is now widely used in large-scale farming areas in South Korea, Japan, Latin America, and Southeast Asia. How do you view this approach to modern agriculture? The watermelon harvest season usually lasts from May to September in the Northern Hemisphere, while in the Southern Hemisphere in countries such as Brazil and Argentina, it falls between November and March, ensuring that this fruit is available almost year-round on the global market. Harvesting watermelons is a delicate balance of strength and precision. Unlike grains or corn, these fruits, often weighing up to 1,000 times more than a strawberry, are far too fragile to be harvested entirely by machines. Most are still picked by hand. Farmers walk row by row, tapping the melons and listening for the hollow sound that signals ripeness. Once a fruit is chosen, they cut the stem with a small knife and gently set the melon down to avoid cracking its thick yet brittle rind. It is a task that demands coordination. If a worker becomes careless or impatient, the heavy fruit can easily be damaged or shattered. Timing is also critical. Watermelons must be harvested early in the morning when temperatures are cooler, preserving their firmness and sweetness. Every year, more than 100 million tons of watermelons are harvested worldwide, with China alone contributing nearly 60% of the supply. The bountiful orange harvest runs from October to May in the Northern Hemisphere, and from June to December in Brazil, making the global harvest season more vibrant than ever. In 2025, Brazil continues to dominate the world's orange industry, with an expected output of more than 16 million tons, accounting for nearly 20% of global production. The United States, particularly the state of Florida, produces around 4 million tons, mainly serving the orange juice processing industry. On large-scale farms, using hydraulic shakers, it takes only a few seconds to shake an entire tree, causing thousands of oranges to fall onto canvas sheets, achieving an average yield of 6 to 8 tons per hour. To meet soaring demand, orange farms are turning to machines that harvest faster and smarter than ever. Among them, modern combine harvesters such as the Oxbow 3220, the New Holland VX790, or the Corvin 9000 series move between rows of trees using vibrating rods and automatic conveyors to detach the fruit and collect it into bins. These machines are capable of harvesting more than 20 tons of oranges per day, nearly 3 times faster than hydraulic shaker systems, and over 40 times more efficient than manual hand-picking. Each year, the world harvests more than 80 million tons of oranges, supplying raw materials for a juice industry worth over 30 billion USD. Famous brands such as Tropicana, Minute Maid, and Cutral hold the majority of the global orange juice market. Tropicana alone processes more than 5 million oranges daily at its factories in Florida, producing millions of liters of 100% pure orange juice. The oranges that meet quality standards are packed for the fresh market, while the rest are sent through cold pressing, filtering, concentration, and aseptic bottling lines, the journey that creates the familiar morning glass of orange juice enjoyed around the world. Billions of potato seeds are planted in the early spring of the Northern Hemisphere and the autumn of the Southern Hemisphere, marking the beginning of one of the most important crop seasons in global agriculture. Across vast fields, modern potato planters such as the Lockwood 608, Grimm GL 420, and John Deere 1725 operate tirelessly, capable of planting more than 12 rows at once, covering 10 to 15 hectares per day. Each seed potato is placed precisely into the soil by conveyor systems and GPS sensors, ensuring uniform spacing and optimal growth conditions. Thanks to this high level of mechanization, global potato production now exceeds 370 million tons annually, making this humble tuber the fourth most important food crop in the world, after rice, corn, and wheat. Germany's deep-field robotics weed control system stands as a revolutionary solution that is transforming the way humans care for crops. Equipped with an AI-powered camera capable of processing up to 20 frames per second and a high-precision image recognition system, the robot can clearly distinguish between crops and weeds, then use mechanical arms or laser beams to remove individual weeds without harming the surrounding plants. Thanks to its ability to operate continuously day and night, the robot can treat dozens of hectares each day without using herbicides, chemicals that are responsible for soil and water pollution in over 60% of Europe's agricultural areas, and the loss of up to 40% of soil biodiversity. However, the main drawback of deep-field robotics is its significantly reduced efficiency under harsh weather conditions, such as heavy rain, sticky clay soil, or uneven terrain. So would you be willing to spend $150,000 to own this cutting-edge technology of the future? After 4 to 5 months of patient waiting, farmers across major potato-growing regions from Idaho and Wisconsin, the Netherlands, Germany, to China enter a vibrant harvest season that lasts from August to October each year. Hundreds of massive harvesters from leading brands such as Grimm, DeWolf, and Lockwood operate in sync with John Deere tractors, manufacturers that together account for over 70% of the global potato harvesting machinery market. The lifting blades, vibrating shafts, and multi-layer conveyors gently separate rows of potatoes from the soil, remove stems and dry dirt, and unload them directly into trucks running alongside. Each machine can harvest up to 150 tons of potatoes per day, turning entire fields into golden brown streams of tubers, a humble crop that feeds more than 1 billion people every day worldwide. According to USDA forecasts, in 2025, the United States is expected to reach a yield of over 20 million tons of potatoes, ranking 5th globally after China, India, Russia, and Ukraine, with Idaho remaining the country's largest production hub, accounting for nearly 1/3 of total output. After harvesting, the potatoes are taken to high-tech storage facilities where low temperatures and humidity of around 95% keep thousands of tons fresh for months. From there, they begin a new journey, becoming crispy fries, smooth mashed potatoes, or potato starch for the global food industry worth over $150 billion each year. Across the arid highlands of Mexico, Sicily, North Africa, and the southern United States, the cactus harvest begins from June to October, a cultural symphony deeply rooted in local tradition. Mexico remains the world's largest producer, accounting for over 45% of global cactus output, with more than 70,000 hectares under cultivation and an annual yield of around 800,000 tons. In the Milpa Alta region of Mexico City alone, over 300 tons of cactus pads are harvested daily, supplying both domestic markets and exports to the United States, Europe, and Japan. Farmers still harvest by hand using thin steel knives or small shovels, usually in the early morning when the spines are soft. In some regions, mechanical cutters are introduced to speed up the process, slicing through the pads and gently lifting them onto conveyors for collection. The young pads are then cleaned, de-spined, and carefully packed for the fresh market, where they are served as salads, soups, or stir-fried dishes, or ground into feed for livestock in arid regions where other forage crops are scarce. Meanwhile, cactus fruits are harvested either by hand or with specialized mechanical grabbers, with each plant producing between 150 and 200 fruits per season. The fruit is known for its refreshing sweetness and vibrant colors, from red and purple to golden yellow, carrying deep cultural significance across Latin America and the Mediterranean. In Mexico, the retail price ranges from 0.6 to 0.9 USD per kilogram, while export-grade fruits can sell for up to 10 times higher. Mexicans often proudly say, "Más mexicano que el nopal," more Mexican than the cactus, a phrase that reflects the spirit of resilience, identity, and national pride deeply rooted in their land. Beyond its cultural and economic value, the cactus also stands as a symbol of sustainable agriculture. It uses up to 80% less water than conventional crops and has helped restore more than 1.5 million hectares of desertified land in Mexico, Morocco, and Ethiopia, earning its title as the crop of the future in an increasingly harsh climate. The 2025 peak blueberry harvest season bursts into life from June to September, painting landscapes around the world in deep shades of blue. Blueberries are divided into two main types, low bush and high bush, each with distinct harvesting traditions and technologies. Low bush blueberries, standing only 20 to 40 centimeters tall, grow naturally in Maine and eastern Canada and are harvested with mechanical rakes or low-ground sweepers for frozen and processed products. In contrast, high-bush blueberries, reaching up to 2.5 meters, are cultivated in Peru, Chile, Spain, and the United States, harvested by self-propelled machines equipped with vibrating conveyors that gently preserve fruit quality. Today, global blueberry production exceeds 2 million tons a year, with the United States and Peru together, accounting for more than 40% of total output, ensuring a year-round supply of this nutrient-rich fruit to markets worldwide. As autumn spreads, alongside the bustling pumpkin harvest for the festive season, fields from North America to Europe glow with the vibrant colors of ripening squash. Modern harvesters, equipped with cutting blades, vibrating shafts, and integrated conveyor systems, work seamlessly to lift vines, separate the fruits, and load them into containers at speeds of over 10 tons per hour. Each year, nearly 28 million tons of squash are harvested to meet the rising global demand for fresh produce, soups, vegetarian meals, and frozen foods, a testament to this golden vegetable crop, one of the most widely cultivated and consumed short-season vegetables in the world. Amid the golden waves of ripened barley, the harvest season unfolds with both grandeur and danger. Farmers face not only volatile prices and market pressure, but also the harsh power of nature, where a single gust of hot wind or a tiny spark can turn vast fields into flames. A single major fire can cut yields by 15 to 20%, causing tens of millions of dollars in losses. Therefore, they must fight back, using tractors to plow fire breaks and spraying water to prevent the flames from spreading. That is how quick-witted farmers save their crops. Even as smoke fills the sky and fire blazes across the horizon, the harvest must go on, because every minute lost means tons of barley reduced to ash. Many of these fires are triggered by overheated combine harvesters, where dry straw and dust accumulate near the exhaust or bearings, igniting instantly under extreme heat. This dramatic scene often unfolds across major barley-growing regions such as Kansas, Alberta, and Ukraine, where humans and nature continue their fierce struggle for every season's yield. Each year, the world produces over 150 million tons of barley, most of it used for beer, animal feed, and malt production. At the same time, thousands of hectares of barley fields are burned, releasing hundreds of thousands of tons of CO2 into the atmosphere and stripping away the fertile topsoil built up over decades. Famous as one of the most delicate and easily damaged vegetables, harvesting celery requires precision, care, and speed in every movement. Across lush green fields stretching from California in the United States to the Murcia region of Spain and the Flevoland plains of the Netherlands, the harvest season begins in October and lasts until early spring. On smaller farms, workers still harvest by hand, using sharp knives to cut each stalk close to the ground, gently bundling and placing them into boxes to avoid bruising. Skilled pickers can harvest between 1 and 2 tons per day, showcasing the craftsmanship of traditional vegetable farming. In contrast, large-scale farms rely on modern mechanical harvesters equipped with cutting blades and automated conveyors that lift, trim, and load celery into containers at speeds exceeding 15 tons per hour. Today, the United States stands as the world's largest producer of celery, yielding over 900,000 tons annually, with California alone accounting for more than 80% of the national output. European countries, such as Spain, the Netherlands, and Italy, also serve as major production hubs supplying the EU market. On the consumer side, China and the United States are the world's top celery consumers, each averaging more than 2 kilograms per person per year, a clear reflection of the global appeal of this crisp, refreshing, and nutrient-rich vegetable. Our mission is to grow the best plants possible for the benefit of humanity. That is the declaration of the creators behind this vertical farming system. Since 2004, they have worked to ensure that even the smallest piece of land can deliver maximum efficiency. And the figures truly speak volumes. The system can deliver up to 26 crop cycles per year while using just 1% of the land area required by conventional farming. At the heart of the design is the patented aeroponic technology they developed in-house. Rather than being planted in soil, root systems are continuously misted with a nutrient spray in a near-zero soil environment. This means the system consumes 40% less water than typical hydroponics, significantly reducing resource waste. Alongside this, multivariable data monitoring allows operators to track and respond to crop conditions in real time, effectively anticipating the mood of the next harvest and reacting accordingly. In the current climate, as of 2025, with global indoor and vertical farming markets expected to exceed $120 billion by 2030, this system positions itself not just as a technology demo, but as a scalable, high-value solution to the looming agrarian constraints of land, water, and supply chain volatility. With just the push of a button, you can instantly produce fresh, nutritious feed for livestock. There is no waste, year-round production, and up to 95% water savings compared to traditional fields. It sounds like a fairy tale, but it is already a reality. On the screen is a vertical hydroponic system designed to improve long-term farm efficiency, something that becomes even more meaningful as the world faces a growing shortage of meat. Even better, this system is environmentally friendly. Higher quality feed can help cattle emit less methane. The system is called HydroGreen, and it comes in multiple configurations. For example, systems designed for 100 or 1,000 head of cattle. Seed sowing, irrigation, and lighting are all controlled by smart automated components. 2 starter-level HydroGreen units can produce around 1,300 pounds of feed per day, while 12 more advanced units can replace approximately 400 football fields of conventional farmland. We are facing an urgent problem that must be solved, the group shared. Can you guess what they were talking about? In the near future, we may no longer be able to keep food prices affordable, simply because our natural resources will be depleted. It is time for a new way to feed the world, or put more simply, a new kind of mobile farm. Instead of expanding on land, they developed a system called Nemo's Garden, a series of dome-shaped greenhouses installed at depths of 5 to 10 meters below the sea surface. Each dome holds up to 2,000 liters of air, maintaining nearly 100% humidity and creating a stable, year-round environment for plants using a hydroponic system. In their experiments, Nemo's Garden successfully cultivated over 40 plant species, with basil showing an increase of up to 31% in antioxidant content compared to soil-grown plants. Thanks to natural underwater pressure and stable temperatures, the system can operate fully automatically without soil, free from most land-based pests, and with almost no need for pesticides. Leafy greens are a foundation. But to truly feed the world, humanity needs much more. especially reliable sources of high-quality protein. And on the open ocean, Norway is leading the charge with a next-generation offshore fish farm. Not far behind, China has also stepped in, acting as a bridge for international partnerships, technology exchange, and the rapid expansion of deep-sea aquaculture. This system operates like a giant steel farm in the middle of the ocean, engineered to raise salmon on a scale the world has never seen. In its initial phase alone, the structure can hold over 22 million pounds of salmon, providing an enormous supply of protein for global markets. Stretching 1,236 feet in length, taller than the Eiffel Tower if stood upright, the facility is divided into 6 independent rearing tanks, each designed for a different stage of the salmon growth cycle. What makes the project exceptional is not only its scale, but its resilience against nature. The structure is built to withstand 33-foot waves, and in severe storms or extreme conditions, the entire platform can be elevated an additional 13 feet to reduce wave impact. All of this is designed to protect the fish and maintain continuous farming operations 24/7. Behind this ambition is an investment of 197 million USDs, signaling a bold commitment to transforming the ocean into the protein fields of the future. Still on the topic of fish, if your business works in municipal or commercial water supply, innovations like this are absolutely within reach. On the screen is a 12,500 square foot tilapia farm, supported by specialists from a U.S. aquaculture company. The team is evaluating the performance of this grow-out cycle. 242 days ago, they stocked the tanks with juvenile fish, and now those fingerlings have grown into market-ready adults, weighing between 1 and 12 pounds. The facility is built around 5 independent recirculating aquaculture systems (RAS), a modern approach that dramatically reduces water use and maintains ideal water quality with minimal waste. Thanks to closed-loop filtration and continuous monitoring, the farm achieved a 2% mortality rate, far better than the original 10% expectation, resulting in a significantly higher profit margin. Production has scaled so efficiently that part of the harvest is already scheduled for long-distance distribution, including a shipment bound for China in time for Lunar New Year. Ordinary bridges can feel dull and uninspiring, so why not transform them into living works of modern art? If you assume such projects are costly or slow to build, think again. This bridge in Germany has become a seasonal icon for its city, drawing attention every spring. Originally constructed in 2000 for an exhibition, the bridge tunnel stretches 49 feet in length, weighs roughly 41,888 pounds, and requires 2,160 individual plant pots to complete its design. Among them are violets, lavender, sage, and wallflowers, creating both visual texture and a natural fragrance. From April onward, residents and visitors can walk through and enjoy a multi-sensory experience. The concept behind the installation is simple yet striking, a harmonious fusion of art, nature, and technology, turning an everyday structure into a public masterpiece. The next project is just as fascinating, a vertical farm that can be built anywhere in the world. It delivers astonishing productivity, up to 350 times more yield per acre compared to traditional agriculture, with a unique modular design and the ability to produce high-quality food all year round. It's no surprise that Driscoll's, a company that once controlled 1/3 of the U.S. berry market, became a strategic sponsor. One of the manufacturer's mottos is, "A farm is only as good as the equipment it runs on." So if our smartphones are more powerful than the computers that sent humans to the moon, then why not apply advanced technology to agriculture? The result is a robotic farming system powered by PlentyOS, using special foam pads instead of soil, along with sensors, AI, and a fully automated robotic operation. Thanks to that, leafy greens such as cabbage, onions, basil, and even berries achieve outstanding yields, with strawberries alone reaching 4.5 million pounds per year. Traditional poultry farms typically house around 15 to 17 chickens per square meter, but with the modern farming model developed by Fit Farm Innovation Team GmbH, that number can be up to 2.5 times higher, while still maintaining animal welfare and operational efficiency. The standard setup is engineered with optimized ventilation, easily replaceable components, and the ability to integrate robotic arms into the production line when needed, from care and feeding to harvesting. Fit supports clients through every stage, from planning and installation to full operation, with configurations that comply with European Union standards. By 2025, Fit's system will be deployed across more than 20 commercial-scale farms throughout Europe, particularly in Germany, Austria, Poland, and the Netherlands. With the continued growth of the EU poultry market and rising demand for protein, Fit is regarded as one of the most practical, efficient, and rapidly expanding models among next-generation livestock technologies. Next comes another standout project, a new model of sustainable agriculture. The innovators behind it believe the time has come to upgrade farming with robotics and artificial intelligence. The result is a fully automated farm that leaves viewers stunned. According to the development team, a 43,000 square foot facility can deliver the same output as a 1.3 million square foot conventional farm. Robots handle all labor-intensive tasks, from lifting and transporting to planting and transplanting. And by placing these farms close to retailers and marketplaces, food loss is dramatically reduced. Today, nearly 40% of fruits and vegetables spoil before reaching consumers. So shortening the supply chain becomes a critical advantage. According to United Nations statistics, even before the pandemic, around 690 million people worldwide were suffering from hunger, more than 10 times the population of France. That is why one of humanity's most urgent missions is to overcome the global food crisis. In response, engineers and scientists have developed mobile farms capable of operating in any climate. Each farm is built inside a 40-foot container, divided into 3 zones: a workstation for operators, a cultivation area, and a compartment for equipment and utilities. The performance is impressive. A single container can yield 4,400 pounds of cucumbers per year and is capable of growing more than 300 different crops, including medicinal plants. Each unit can operate for up to 10 years, and the plant keeper system allows users to monitor and control the entire farm easily through a smartphone. After being brought to the receiving area, the fully loaded bamboo trucks are unloaded and sent directly to the primary processing zone. Here, workers quickly sort the bamboo according to diameter and maturity. Thick, solid culms are separated for use in construction materials or engineered plywood, while thinner and smaller ones are selected for straws and household products. Each stalk is then trimmed to remove roots and branches, and cut into shorter sections about 1 to 2 meters long to fit different production lines. In large-scale factories, automatic circular saws and conveyor systems have almost completely replaced manual cutting. These saw blades can process thousands of bamboo stalks per hour, producing sections with uniform length, clean edges, and an extremely low material loss rate. Next comes the node removal process. in which the inner joints of the bamboo are drilled or lathed off using automated deburring machines, creating smooth, hollow tubes ready for the next stages of processing. After being cut into sections, the bamboo is transferred to the washing line, a crucial stage that determines the quality and durability of the final product. Each piece first passes through large water tanks, rotary drums, or high-pressure water spray systems to remove mud, dust, and any remaining leaves or branches on the surface. For export-grade or food contact products such as straws, chopsticks, and spoons, the bamboo is soaked in hot water or a mild alkaline solution such as hydrogen peroxide or diluted baking soda for 4 to 8 hours. This step is extremely important as it sterilizes the bamboo, removes natural sugars and starch, the main causes of mold and insect infestation, while helping preserve its natural bright color. A more advanced version of bamboo material is strand-woven bamboo, a type of material made from bundles of bamboo fibers instead of whole columns or traditional strips. After being cut and carbonized, the bamboo is not split into strips but rather crushed or separated into long fibers, then dried and mixed with bio-based adhesive or heat-resistant resin to create bonding. When reaching the ideal moisture level, the fibers are evenly layered, each layer arranged in a different direction to enhance strength. These layers are then pressed in a high-temperature hydraulic press to form dense strand-woven bamboo blocks. Thanks to its fibrous structure, this material has mechanical strength up to 25% higher than oak or teak, while being almost completely resistant to cracking, bending, and moisture, with an average price of $1,900 to $2,000 USD per cubic meter. After cooling, the bamboo blocks are planed, cut, sanded, polished, and coated with natural oil or wax to protect the surface, giving them a service life of up to 25 years. Today, strand-woven bamboo is widely used in high-end furniture, industrial flooring, and sustainable architecture. The global bamboo materials market is currently valued over $70 billion USD, with laminated and strand-woven bamboo accounting for nearly 35% of the total value and growing steadily at over 10% per year. How are the surplus byproducts from production, such as bamboo dust, fine powder, and fibrous fragments left after cutting, turning, and polishing, fully utilized? The answer lies in bamboo powder technology, a breakthrough that transforms all bamboo waste into a new source of bio-based material. All remaining fragments and bamboo dust are collected, dried, and finely ground into powder, with particle sizes ranging from 80 to 120 microns. This powder is then mixed with other ingredients. The company does not disclose the details, but the formula includes cornstarch, minerals, and a biological adhesive they call bioadhesive. Yet behind this innovation lies a complex reality, where science, safety, and policy often collide. The formulas for composite bamboo materials vary among manufacturers, and not all are safe. Since 2022, the European Union has banned the import of food containers made from bamboo plastic composites due to concerns about toxic chemical leakage, especially when exposed to heat. From a broader perspective, even traditional plastic containers pose health risks, with evidence showing they can disrupt hormones and reduce fertility. Therefore, if bamboo-based products are certified safe and truly biodegradable, they have strong potential to become a sustainable alternative to plastic. When compared to paper, recycled paper remains the best option, with a carbon footprint only 1/3 that of paper made from bamboo or virgin wood, making it the most sustainable choice today. However, bamboo is still a valuable second-best option. Though not as efficient as recycled paper, it is far more eco-friendly than harvesting natural forests. Ultimately, even renewable resources like bamboo can have environmental impacts if overexploited. When managed responsibly, bamboo can offer great potential for the green economy, even though the price of eco-friendly products remains high. For example, at Walmart, a roll of real paper bamboo toilet paper costs $1.67, while a Charmin wood pulp roll costs about $1.25. Nevertheless, more and more consumers are willing to pay extra to support sustainable products. So, what do you think about the future of bamboo materials? Share your thoughts in the comments below.